In this question, we want to use the graph of y equals 2 to the x and transformations to sketch the exponential function f of x equals negative 2 to the x plus 3. We want to determine the domain and range, determine the y-intercept, and find the equation of the horizontal asymptote. To start off, we're going to use coordinates, ordered pairs, from the graph of y equals 2 to the x to determine the corresponding points on the graph of y equals negative 2 to the x plus 3. So we're going to start off by analyzing the function f of x equals negative 2 to the x plus 3 to see what type of transformations we have. So as I look at this function, I notice that the base graph will be y equals 2 to the x, and these ordered pairs listed here are ordered pairs that are on that graph of y equals 2 to the x. And then we have two transformations that are occurring on our function f of x, and they correspond with the negative and the plus 3. The negative is a reflection, and because that negative is outside of our base function, it's a vertical reflection. The plus 3 is a shift. Anytime we have adding or subtracting, it's a shift. And because that plus 3 is in the exponent inside the base function, this is a horizontal shift. And because it's a plus, it's going to shift left 3 units. So these are the transformations that we have. And what we want to do is use those transformations to determine what happens to this ordered pair. So we're going to start with the transformation of shifting left and then do the transformation of reflecting vertically. Sometimes it's helpful to imagine this on the grid itself. So if we have the ordered pair negative 1, 1/2, negative 1 and 1/2 would be about right here. And we want to do the transformation of shifting that ordered pair left 3 units. So that ordered pair would shift left 1, 2, 3 to here. And you can see that the y value at the original coordinate and the y value at the new coordinate are exactly the same. So our y coordinate is not changing for the transformation of shifting left 3. However, the x coordinate has changed. It started off being negative 1, and when we shifted it left 3, we took that negative 1 and subtracted 3 to get negative 4. So the new coordinate would have an x of negative 4. Then we want to do the other transformation of reflecting. Reflecting vertically means to take any points that are above the axis and reflect it to become below the axis. So this ordered pair that I'm highlighting here is 1/2 above the x-axis, and I'm going to mirror and reflect it to be below. So that y-coordinate changed, the x-coordinate stayed the same. So this point now becomes negative 4, negative 1/2. So that's where the new ordered pair would be. We're going to do the same thing for these other two coordinates. So I'll start off with an ordered pair of 0, 1. we want to shift that ordered pair to the left 3. So that means that the x-coordinate of 0 subtracted 3 becomes an x-coordinate of -3. The y-coordinate doesn't change. Then we're going to reflect over the x-axis. That's a mirror image over the x-axis. Excuse me, this y-coordinate is a 1. And when you reflect over the x-axis, it becomes -1. And then for the final point, we have the coordinate, the ordered pair 1, 2. We're going to shift left 3. So that x-coordinate becomes -2. We take the x-coordinate and subtract 3. We move to the left 3, that's why we subtracted 3. And then on the reflection, we're 2 above the x-axis and we'll reflect down to be 2 below. So that moves to the ordered pair of -2, -2. The next thing we want to do is to graph the function f of x equals -2 to the x plus 3. So we've already found some new ordered pairs that will be on the graph. And those ordered pairs are -4, -1/2, -3, and -1, and -2, -2. So if we recall that exponential functions have horizontal asymptotes, and the original horizontal asymptote for y equals 2 to the x is at y equals 0. And based on the transformations that we have shifted left 3 units and reflected over the x-axis. With those two transformations, they have no effect on our horizontal asymptote. It's going to be in the same place. So our horizontal asymptote is the line y equals 0. And so on this piece of the graph, we can see that the y values are getting closer to that x-axis, closer to a y value of 0. And then on the other end of our exponential function, the graph will be going to infinity. Should probably spread this out just a little bit. So this would give us the graph of this exponential function. We found those coordinates earlier, and we did the transformations on them. So the next thing we want to do is to find the domain of our new function, -2 to the x plus 3. Now when we're finding domain, I like to hold the ruler vertically and go from left to right. The first time my ruler is hitting the graph would be at -infinity, and it continues to positive infinity. The domain of this exponential function is -infinity to infinity, or all real numbers. Then we want to find the range. I'm going to hold my ruler horizontally and go from bottom to top. The first time I hit the graph with my ruler would be at -infinity, and I would continue hitting the graph until I get to the x-axis. That's where that horizontal asymptote is, and the graph is going to get closer and closer to that horizontal asymptote without ever reaching it. So the range for this would be -infinity to 0. The next thing we want to do is find the y-intercept. You find a y-intercept by letting x equal 0. So I will substitute a 0 into our function. F of 0 is negative 2 times 0 plus 3. That's negative 2 to the third power. And 2 to the third power is 8, and we carry that negative over. So we have a y-intercept at 0, negative 8. So I could do a little bit better job of drawing this portion of the graph now that I know where that y-intercept is. And the graph will cross at negative 8. And finally, we have our horizontal asymptote, which I already mentioned is at y equals 0. In this question, we have the original investment of $11,000 earns 6.75% interest compounded continuously. What will the investment be worth in 1 year and also in 10 years? So one key word in here is that our interest is compounded continuously. And that's an indication of which compound interest formula that we're going to use. We're going to use A equals P times E to the RT. So anytime your interest is compounded continuously, this is the formula that you're going to use. We have the original investment, that's going to be our principal of $11,000. We have our interest rate of 6.75%. We'll use that for R. So R is 6.75%, and we'll put that in decimal form to use it in our formula. That's 0.0675. And then we have two times. We have a time of 1 year and a time of 10 years. So we're going to have to do this calculation twice, once for 1 year and then again for 10 years. So let's do the calculation for a time of 1 year. That's A equals 11,000 e to the 0.0675 times 1. I'm going to type this in my calculator. 11,000 times e to the 0.0675 times 1. So after 1 year, your account would be valued at $11,768.13. Let's do the calculation for 10 years as well. That would be 11,000 as the principal, e to the 0.0675 times 10. Once again, I'll type that in my calculator. We have 11,000 times e to the 0.0675 times 10. And after 10 years, the $11,000 would grow to be $21,000, $21,604.34. $0.36. Thank you for checking out my videos. Have a great day.